Hello children. Now I will be explaining you chapter 13 electric currents and its effect. Grade 7th. Okay. So electric current, what is electric current? Whenever you switch on any of the appliances, it start working. So what the energy is behind this working? It is electrical energy, and that's something that is working. It is electrical current. Okay, so the electrical current consists of electrical energy. The form of energy in the electric current is electrical energy. Okay, now how it is flowing? It is flowing in a electrical circuit. The arrangement where an electric current flows in a conductor connected to it means whenever you switch on any switch, the electric current is passed through the wires, as you can see, and then it is flown into the appliance that you are switching on. Okay, then it starts working because of the electric current. Next, now if we talk about the components of an electric circuit, means what electric circuit consists of. The first component is battery or the cell. So cell means the source of energy. So as you switch on the light in your houses, the energy is coming from any of the powerhouse. Okay, now if you talk about a simple wristwatch that you are wearing, the source for the energy of working of your wristwatch is the single cell that you put inside your wristwatches. Okay, now if we combine many cells, it becomes a battery. Okay, so now whenever we join more than one cell, what we do, we connect the positive terminal to the negative terminal. Okay, then only the combination will work. Okay, next, the next component is the switch. Okay, so what the function of your switch? Whenever you want to switch on appliance, then you switch on it. If you want to switch off it, then you switch off the switch. Okay, so now how it is working? When the switch is off, your circuit is open. Open means like this. If you see a simple circuit, I say this is a circuit. Okay, now if I say if this is a switch, okay, wait. This is a simple circuit. Okay, now this part is your switch. Okay, this part is your switch. Now if it is open, means the switch is off. Okay, this is known as open circuit and the switch is off. Clear? Now if this is touched, if this is touching each other, okay, now if this is touching it, now what is happening? This circuit is closed. The circuit is termed to be closed and the switch is on. Clear? So whenever you on your switch, the circuit is closed. Whenever you off your switch, the circuit is open. Clear everyone? Okay, now next, so what is the function of your switch? To maintain the flow of the current. When the switch is off, the circuit is open and the current is not flowing to the appliances. Whenever the switch you on it, then the circuit is closed and the current is flowing through the circuit to your appliance. The next is your appliance, whichever you are providing your electric current, like simply your bulb, your rod, your all these are known as your appliances. Now while your bulb, if I say about your bulb, it is glowing. So what is the part thing that is making it glow? It is known as your filament. The wire, the thin wire that you can see inside your bulbs, it is known as filament that help us to glow the bulb. Okay, next, conducting wires means whenever you switch on electric board से आप switch on करते हैं, then the electric current is passing to your appliance, so it is connected all the way through the conducting wire. The wire form a path through which the current is flowing from the switch to your appliances. Okay, now these are mostly made up of copper wires. These are made up of copper wires which provide very low resistance. We will understand the term resistance in further. Okay, resistance is very important in concept of your wires. Okay, now so now the for the conducting wires we used uh, metal that show very little resistance. For the filament that is used for glowing of the bulb, we use very high resistance metal like tungsten. Okay, now why we use this high resistance metal, we will understand it later concept. Okay, now components such as bulb, wires, cells, or batteries, switches are known as the elements of the electric circuit. These are known as elements of the electric circuit as well as the components of the electric circuit. Okay, so how we can simply define an electric circuit? An electric circuit is a continuous conducting path for electric current consisting of a source of current such as an electric cell and other circuit elements such as a lamp, conducting wires, and a switch. Clear? Now circuit diagram, as if we cannot directly draw the battery, or if you are supplying current to your fridge, you cannot draw that fridge. So simply how we can represent the circuit in a form of a diagram. This is your diagram. This this is your battery. These are your conducting wires. This is your appliance, means bulb, and this is your switch that is controlling all your current flow. Okay, now the next topic is potential difference. Okay, so as I have discussed in the class also, that potential difference means when anything flows from its higher concentration to its lower concentration. Wherever the pressure is higher, wherever the concentration is higher, it will always flow to the lower level concentration or pressure till both are same. Both the vessels, like this in example, both the water will flow from the higher to the lower level of the water till both the levels are same. Okay, so in a circuit you can understand like this. Whenever you put the this is your cell, so your positive terminal and negative terminal, positive terminal it has higher potential, negative terminal is at lower potential. Clear? So positive, whenever we are drawing the circuit diagram, we mark positive potential and the negative terminal. Positive terminal it has higher potential, negative terminal it has a lower potential. Okay, so this is given in this part. The positive terminal is at a higher potential than the negative terminal. Okay, now effects of electric current, as the chapter says, electric current and its effect. Now what are the effects of electric current? Simply the first effect is heating and the lighting effect. Okay, heating and lighting effect means whenever you turn on any of your appliance, okay, if you turn on your rod for some time and after some time you touch your rod or the bulb, it is heated. Yes, it feels warm to touch it. So the light that you have turned on, the electric current passing through that appliances make it warmer, make it hotter at its place. Clear? So the first effect of the heat is whenever you pass current through any of the wire, any of the appliances, the first effect is heating effect. It get heated, it get hotter. Next, lighting effect. Okay, whenever you switch on your in winters you generally use your room heaters. So room heaters, what happen, after some time they glow. So why they are glowing? The first effect they have shown that all the coils in your room heater has get warm, heated, then it is showing lighting effect. Because of the heat they are now showing your lighting effect. Okay, so the first effect is your heating effect, after that it is showing your lighting effect. Now over here I explain you the concept of the resistance. What is resistance? Okay, now simply understand the concept resistance like this. Okay, so if you are going on a road and anyone is stopping you, you are going on a path and anyone is stopping you, feel angry. Okay, so now this is the same concept. Whenever the electric current is passing through any wire or anything, it shows resistance, means that wire is stopping it to grow from it. Okay, so any metal, for example like copper, it is showing less resistance, means it is easily letting the electric current to pass through it, so it is having low resistance. Metals like tungsten, it shows high resistance. High resistance means whenever the electric current tries to pass through it, it shows more resistance to it, stop it more. So this is high resistance and this is low resistance. Whenever the metal is allowing the current to easily pass through it, it is having low resistance. The metal, those who show high resistance, it stops the current to pass through it. Now how it is being used over here? Okay, so now suppose if whenever you touch on your switch and it is passing through the wires that are inbuilt in your walls that do not show outside. आपका जब घर बनता है तो सारे के सारी वायरिंग क्या हो जाती है, अंदर हो जाती है. Okay, now if all those wire would have heated, so this was the loss of energy. These are the every wire should have got heated up. So do we require to be every metal to be heated, every wire to be heated? No, we want the electric current to be passed through the appliance in which we want it. Okay, so all the wiring where we do not want it should be heated up, we use low resistance wire. Now in a bulb where we want that whenever the electric current is passed through it, it shows heating effect and very soon the lighting effect. तुरंत आप बल्ब जलाएंगे तो वो क्या करेगा, आपका टंगस्टन जो होगा वो उसको हाई रेजिस्टेंस देगा, करंट को पास नहीं होने देगा, तो वो क्या करेगा, हीट की वजह से गुस्सा होगा. यस, आई कंसेप्ट इसी से याद रखिएगा. तो आपको जब पास नहीं होने दिया जाएगा तो क्या करेंगे, so it is heated up and then it is showing you the lighting effect. Clear? So like room heaters, like your bulbs, we use high resistance wire so that it shows easily the lighting at the heating effect. Clear? Now, so lighting effect we have covered. Next is your fuse wire. Okay, so now the fuse wire concept. Okay, everyone has seen the fuse in your houses, the main switch from where your electricity is controlled. The main switch of your house, घर में एक आपका main fuse होगा जहाँ से आपकी electricity घर में आती है. Okay, over there a wire is being used. Now the MCBs are being used, but जितने पुराने थे पहले क्या यूज होते थे, फ्यूज वायर्स. तो फ्यूज वायर में क्या होता है, a wire with low melting point is used. Now melting point, where the concept comes. Okay, now whenever there is a short circuit, means okay, if your transformer have transferred high voltage or from powerhouse or anything, the high voltage or any short circuit inside your house is happening, so immediately a high voltage is provided, so it can influence all the appliances in your houses in which your electricity is being passed. So what the fuse does, whenever a high voltage pass through it, it melts out. So that is why we use a low melting point, so that whenever a high voltage pass through it, it melts down and break the circuit. अभी ऊपर पढ़ा था कि अगर circuit complete नहीं होगा तो वो switch off हो जाएगा. So similarly, whenever the high voltage is passing through the fuse wire, due to its low melting point, it melts down and it breaks. अब वो घर के अंदर तक उस हाई वोल्टेज को आने नहीं देता, पहले ही वो फ्यूज वायर क्या हो जाता है, ब्रेक हो जाता है. क्लियर? सो दिस इज हाउ द फ्यूज वायर्स वर्क. ओके, सो शॉर्ट सर्किट में फ्यूज वायर यूज होता है. फ्यूज वायर अलॉय का होता है जिसका क्या होता है, लो मेल्टिंग पॉइंट होता है. क्लियर? नेक्स्ट, miniature circuit breaker, MCB. In today's date, everywhere MCBs are being used. The same work does the MCB. It does not break down the wire, it does just switch off it. MCBs goes down, नहीं कहते हैं MCB down हो गई. So MCB down means whenever the current exceeds its specific limit. Like in the previous one we used a wire that has a low melting point, so that was the fixed limit for it, its melting point was a fixed point. Next, in MCBs we have done the same thing. It ऑटोमेटिकली स्विच ऑफ, एमसीवी ऑफ हो जाती है वेन एवर द करंट एक्सीड्स इज अ मैक्सिमम लिमिट, उसकी जितनी लिमिट है उससे ऊपर, देन वेन एवर द वोल्टेज इज easily available at the specific limit, then you can switch on your mcvs and use your batteries. Okay, now next, magnetic power. Now next concept is magnetic. The third effect is, first we have understood heating power, then lighting effect, then magnetic effect. Now magnetic effect, simply understand by this effect. Okay, simple. Whenever anyone touches high voltage, वो उस पे जहाँ पे चिपक जाता है, तो चिपकने का इफेक्ट तो मैग्नेट से ही रिलेट करता है। सो इसको याद रखिए, अगर कहीं पे बहुत ज़्यादा इलेक्ट्रिक करंट पास हो जाता है तो वो क्या करने लगता है, मैग्नेट की तरह काम करने लगता है, वो किसी भी चीज़ को आपको चिपका लेगा। क्लियर। सो थर्ड इफेक्ट इज मैग्नेटिक इफेक्ट। मैग्नेटिक इफेक्ट हमारा कहाँ आता है, हम कैसे टेस्ट कर सकते हैं, अगर हम किसी वायर में करंट पास करें और उसके पास एक कंपास लेके जाए, कंपास कैन आइडेंटिफाई द मैग्नेटिक फील्ड। ओके, सो हम कंपास लेके जाएंगे, सो इट विल शो द डायरेक्शन, इट विल डेविएट इट्स नीडल बिकॉज ऑफ द मैग्नेटिक करंट दैट इज पासिंग थ्रू द वायर। क्लियर। नाउ so Oersted in 1820 tested for the magnetic effect of the electric current. Clear. In 1820 it was tested that whenever the electric current is passing through any of the wire, it also shows the effect of the magnet. Okay, now the same application is done in the solenoid. The magnetic effect is used in the solenoid. Solenoid is what? Now okay, now let us see the setup of the solenoid, how the solenoid is seen. Okay, so this is your solenoid. What we have done, okay, earlier we have seen the electric circuit that was like this. This is your battery, this is your switch, conducting wires, and this is the straight path. Now what we have changed, in place of this single wire we have just made the turns out of that wire. Yes. So what now, what has done this turns, what the application of these turns? Okay, now see, if I suppose that over here 1 meter wire was used in this distance, in the same distance now 5 meter wire is being used, because of the coiling up more wire is being implied in this specific area, इतने ही area में आपकी wiring बढ़ गई। yes, now if I say that 1 meter wire में जितना heating effect, जितना lighting effect, जितना magnetic effect हो रहा था, वो यहाँ 5 times बढ़ जाएगा। सेम 1 मीटर में जितने इफेक्ट्स आ रहे थे उतने ही 5 मीटर्स में आपके इंक्रीज हो जाएंगे। सो दिस इज द एप्लीकेशन ऑफ सोलेनॉइड। इट इज अ सिलेंड्रिकल कॉइल्ड वायर्स, द कॉइलिंग ऑफ द वायर मेक इट अ सोलेनॉइड। नाउ हाउ वी कैन इंक्रीज द स्ट्रेंथ ऑफ अ सोलेनॉइड, हम सोलेनॉइड की स्ट्रेंथ कैसे इंक्रीज कर सकते हैं, इंक्रीजिंग द नंबर ऑफ टर्न्स। यहाँ पे जितने टर्न्स हैं, हम जितने ज़्यादा टर्न करने का मतलब उतना ज़्यादा वायर उतने कम जगह में आ जाएगा। यस, इंक्रीजिंग द करंट, जितना ज़्यादा करंट उतना स्पेसिफिक आपका, उतना ज़्यादा आपका सोलेनॉइड हो जाएगा। वाइंडिंग द सोलेनॉइड अराउंड अ मैग्नेटिक मटेरियल। नाउ अगर हम इसी कॉइल के बीच में ऐसे एक रॉड डाल दें जो कि आयरन की, किसकी, कोबाल्ट की या निकल की, मैग्नेटिक मटेरियल सीन होते हैं आपके आयरन, कोबाल्ट, निकल, अगर उसमें से किसी की भी रॉड इसके बीच में इंसर्ट कर देते हैं तो ये सोलेनॉइड की क्या हो जाती है, पावर और इंक्रीज हो जाती है। इसी सोलेनॉइड को हम क्या कहते हैं फिर, इलेक्ट्रोमैग्नेट। इसी को क्या बोलते हैं हम, इलेक्ट्रोमैग्नेट। जब हमारा इसके अंदर आपका क्या हो जाता है, एक आपका मैग्नेटिक मटेरियल का बार इंसर्ट हो जाता है। क्लियर। नेक्स्ट, सो इलेक्ट्रोमैग्नेट, an electromagnet is a coil of insulated wire wound around a piece of magnetic material such as soft iron. It acts as a magnet only as long as the current is flowing through the wire. So what we have done in this circuit, this is an setup for solenoid. What we have done, we have inserted a core of a magnet. Now what are the uses of the electromagnet? Simply, have you seen the junkyards? junkyards में बहुत सारी कार्स होती हैं, आपका बहुत ज़्यादा स्क्रैप में आयरन होता है। अब उनको उठाने के लिए क्या किया जाता है, वी यूज़ इलेक्ट्रोमैग्नेट्स। इलेक्ट्रोमैग्नेट्स कैसे मैग्नेट हैं, उनमें मैग्नेटिक पावर तभी तक है जब तक उनमें इलेक्ट्रिक करंट पास हो रहा है. क्लियर? सो वेन एवर वी वॉन्ट टू पिक अप समथिंग वी टर्न ऑन द electric current, it becomes a magnet. It pick up an iron piece, it keep it on the other place, and whenever we switch off the electric current, it does not act as a magnet and it leave the iron piece over there. Like in the ships also, जो बड़े बड़े कंटेनर्स आपके एक जगह से दूसरी जगह ट्रांसफ़र होते हैं, किसकी हेल्प से होते हैं? इलेक्ट्रोमैग्नेट्स की हेल्प से आप यूज़ कर सकते हैं. आपके इलेक्ट्रोमैग्नेट्स आपके घर में जितने अप्लाइंसेस होते हैं, लाइक योर वॉशिंग मशीन्स, एयर कंडीशनर, रेफ्रिजरेटर, everywhere the electromagnets are being used to amplify the effects of the electric current. Now, one application is given for your electric bell, in which your electromagnet is being used. Now you can see the diagram wherever the electromagnet is when, so how it is applied. The hammer, yes. Now switch, you can see the switch. दिस इज द स्विच दैट यू आर टचिंग इट. घर के बाहर जो आपकी बेल लगी रहती है, दिस इज द मेन पॉइंट. वेन एवर यू टर्न ऑन द बेल, दैट स्विच कनेक्ट्स, इट कनेक्ट्स द current and it is flowing in this direction. Clear? Now this direction, now it is going in the electromagnet. इलेक्ट्रोमैग्नेट क्या करेगा? ये आपका जो इलेक्ट्रिक आपका आयरन बार है, ये क्या है आपका? ये आयरन रॉड आपकी, इस आयरन रॉड को क्या कर देगा? हैमर को इधर की तरफ आपका पुश करेगा, जिससे कि ये गोंग में आपके पुश होगा, जिसकी वजह से क्या होगा? आपकी बेल रिंग करने लगेगी. क्लियर? सो हाउ वी हैव डन, हम सबसे पहले क्या करेंगे आपका, we will touch the switch that is present outside the houses. It will start flowing the current, it will go into the electromagnet, it will attract this iron bar towards it. Now with this iron bar, this hammer is attached, this hammer will push the pressure on the gong and this will be ringed. Okay, so this was your concept of your electric current and your effects. Clear? Thank you children.